Hey guys, welcome back. In this video, I'm going to do integration by parts, but in some cases where you basically get the question back, so it's like it's repeating itself. Okay, so this one is a little bit trickier than the basic integration by parts. So let's take a look. So we have to do integration by parts here because you can't do a perfect U substitution. We know Liate, okay? And we know that basically algebra, which is negative 2x, goes to the left, cosine angle goes to the right with dx. The derivative of negative 2x goes there, and the integral of cosine angle is going to be sine angle. Remember to divide by the derivative of the angle if you're going to skip the u sub. Okay, so the derivative of 2x is 2, and I'm going to divide by it. Once you're done, you're going to make your check. I'm going to do it with a highlighter. This times this minus this times this. Okay, so I got negative 2x cosine 2x dx to equal to negative 2 times a half is actually just negative 1. So negative 1x sine 2x, and then minus the integral of this times this. But that's already a minus, and a 2 times a half again gives you 1. So I'm going to have a positive sine angle dx. So in this case, I'm not going to repeat, and this is just basic. What's the integral of sine angle? Negative cosine angle. But if you're going to skip a u sub, you got to remind yourself to take the derivative of the angle and divide by it. So that is how you basically do this problem. Once again, all you have to do is identify algebra, trig, put the algebra on the left side, the trig on the right side, and then you just do your derivative and your integral, and make sure that everything, when you take the antiderivative, that you make sure you watch out for skipping the u sub part. So let's take a look at the next example. E to the x sine x. Well, in Liate, exponential and trig goes to the left. Exponential goes here. The derivative of sine is cosine, and the integral of e to the x is e to the x. You're going to make a check, and you're going to go e to the x sine x minus the integral of e to the x cosine x dx. Well, you're going to have to do that again because I'm not done, because I have this integral. So when I do it again, I get, once again, trig to the left, e to the x to the right. I'm going to take the integral, I'm going to take the derivative, and in this case, I'm going to have minus, we're going to do this times this. That's going to be e to the x cosine x minus the integral of this times this, which is going to end up being a positive sine x e to the x. So I hope everybody sees that. I have to erase this, unfortunately, because I don't have enough room. And so you got to be very, very careful here. I'm going to also erase this part here. So the question now looks like this. What is this? And my answer actually looks like this. E to the x sine x from here. And now I have minus, right, that I bring down here, and the integral of this. So I'm going to have minus e to the x cosine x. And then I have a minus the integral of sine x e to the x dx. My apologies. Well, I basically have this question, and I also got it back. Anytime you get back the question, you have to add it to the other side. So I'm going to add this integral to this side here. So I'm going to have 2 of these. And all I have to do is now divide. How cool is that? All of these integrals need a plus c, by the way. So you get e to the x sine x minus e to the x cosine x all over 2. We did that because we would have just kept going on and on forever. So once you see your question, you have to add it to the other side. Okay? And so that's how you do that. I have one more problem, I believe. Maybe two. Yeah, 2 problems. Okay, here we go, everybody. Algebra, exponential. Algebra goes here, exponential goes here. The integral of e to the x is e to the x. The derivative of x squared is 2x. You make your little check, like we always do, and you're going to say that's equal to x squared e to the x from this part right here minus the integral of 2x e to the x dx. Now we have to do this. So I have 2x here. You could actually leave the 2 out, but doesn't matter at this point. 2x here, and I have e to the x dx here. I take the integral, I take the derivative, and then I'm going to say, okay, this here is going to be 2x e to the x minus the integral of 2e to the x dx. Okay? So that's from this part here that I just erased. You can pause the video, guys, if I'm going too fast. X squared e to the x minus, and now I have 2x e to the x minus 2e to the x dx. This is easy to integrate. You got to keep going until the integral signs are gone. Nothing repeats here. You just have to repeat the process, but the question doesn't pop up again. Okay? One more problem. One more problem. Pause the video, guys. Slow down the video. Watch it at your own pace. Our final problem's right here. In Liate, L, which is the natural log of negative 3x, and then A for algebra, which is this here. The derivative of the natural log of negative 3x is going to be 1 over the inside times the derivative of the inside. So this cancels out with this. Okay? The integral of this is you add 1, so it becomes negative 2, and then you divide by negative 2. So that here becomes negative 3x to the negative 2. So now you make your check. Okay? So you get negative 3x to the negative 2, natural log of negative 3x from this part here, minus, and now you got to do negative 3x squared times 1 over x. So remind yourself that negative 3 over x squared is negative 3x to the negative 2, 1 over x to the first. So that's going to be negative 3x to the negative third dx. You will add 1, so this becomes a plus. You will add 1, and then divide by the new exponent, and then you get this here as your final answer. So there's a negative here, you could just put it right here, and then make this positive. So that's how you do these Liate problems. So I hope you understand it. Go back and watch the video slowly if you don't.